Well, in the previous video, we talked about how to take an equation that's written in standard form and put it in vertex form. And today we're going to be looking at, in this video, we're going to look at a common equation that's in standard form, which is the height of an object. So here's the formula that you want to make sure that you know. H equals -1/2 times g times t squared plus v sub 0. This is a 0. And this is a 0. We call this v sub 0 and h sub 0. We'll talk about that in a second. But this formula you want to make sure that you memorize. You want to make sure that you get that in your notes. It's going to be an important one. So let's make sure we understand what each of these parts represent. So this is a formula for the height, or h, of an object at a given time in seconds. Okay, so time will always be in seconds. If they give it to you in minutes, which I doubt they will, you'll want to change that to seconds. But that's what units need to be for time. Now the height can be in feet or meters, because we'll talk about that in a second. But the v sub 0, that represents the initial upward velocity. So as soon as the ball gets kicked or thrown or shot out of a cannon or whatever the case is, the initial upward velocity is the velocity at that initial point where it's released. And then same thing with h sub 0. H sub 0 represents the initial height, referring to the height of the ball after it's kicked or thrown or launched or whatever the situation is. Now we have this value g that we haven't talked about yet. That value g represents the gravity, the force of gravity, which represents, if our units are in feet, we're going to use 32 because when we're in feet, gravity is 32 feet per second squared. Or if our units that we're using is in meters, our value for g is going to be 9.8 meters per second squared. Now, one of the reasons why this formula is in this section is when we're given this information, oftentimes it's important to know when is that ball going to reach the highest point. Well, that's where the vertex comes in so handy. The vertex, remember the vertex is a point H and K. The vertex is going to be the height of the ball, and the K is going to be, the vertex, the time is going to be the X, or H part of your vertex, and the K, or the Y part of the vertex, is going to be the maximum height of the ball. And later on in the next chapter, we're going to learn how to find this given the standard form of an equation. So in this chapter, or in this section, I should say, they're introducing this formula. But in the next section, that's where we're going to be able to pull from this the vertex to be able to find how high the ball is going to reach. But let's look at some examples. Now, for the examples that they're given to us, they're going to give us the formula, but just make sure that you have that formula written down, because in your assignment and on the quiz and on the test, you're going to have to know that formula. Okay, so it says a ball is thrown from a height, or a thrown ball has a height h equals -16t squared plus 59t plus 4 after t seconds. So we want to find h when t equals 0, 1, 2, 3, and 4. So we want to find the height of the object at these given times. So to do that, what we're going to do is we're going to create a table. So t represents your x-axis and h represents your y-axis. So the time is going to be at 0, 1, 2, 3, and 4. So what we're going to do is we're going to put these numbers into our calculators. Actually, before we go to a calculator, let's talk about something for a second, because we want to figure out what our value is when t is 0. Well, that's going to be an easy one. We don't need a calculator for that, because if you think about it, if you put t in there for 0, we're going to get 4 as our answer for h. In other words, after or before any time has passed, the height of the ball is already at 4 feet. And so let's find the values, though, when the time is 1 second, 2 seconds, 3 seconds, and 4 seconds using our calculator. So if you can see I already started. It's going to be -16 times 1 squared plus 59 times 1 plus 4. So this means that after 1 second has gone by, the height of the ball is 47 feet. If we want to change this now to 2 seconds, if I hit the up arrow twice, it selects what I typed in and then hit enter. And now it copies and pastes it for me. So now I can go through and edit this. So I'm going to change that 1 to be a 2. And then I'm going to go and I'm going to change this one also to be a 2. So this will give me the height of the ball after 2 seconds is at 58 feet. So now to see how high the ball is after 3 seconds, I'm going to go in here, change this 2 to be a 3, and this to be a 3, and hit enter, and I get 37. So what this means now is after 3 seconds, the ball is starting to come back down again, because now it's only at 37 feet, where after 1 second it was up to 47 feet. So now let's figure out what the height of the ball would be after 4 seconds. We get negative 16. So let's talk about that for a second. First off, our table, if we fill this in, would be 47, 58, and then we had 37 and negative 16. So what each of these numbers represent is like 0, like we said, represents the height of the ball before any time has started. The height of the ball is 4 feet high. When t is 2, that means that after 2 seconds, the ball is already 58 feet high. But after 4 seconds, we get negative 16. Now, please do not say that means the ball is 16 feet below the ground. That's not going to happen unless maybe you're Chuck Norris, and then anything can happen. But in this situation, we're not going to, if you throw a ball up in the air after 4 seconds, it's not going to be below the ground by 16 feet unless maybe it fell inside of a manhole. But otherwise, the way that we want to describe this is after 4 seconds, the ball already hit the ground. Or you could say between 3 and 4 seconds the ball hits the ground. It would mean the same thing. Now what we're going to do is we're going to graph this. And I'm going to show you how to graph this by hand. But we're also going to talk about how your CAS calculators can help us out. But first, we do need to know how to do this without a graphing calculator, because you will need to know how to do this on a quiz or a test. So first off, we're going to graph these coordinates. So 0, 4 is halfway between, it's just under halfway between 0 and 10. 1 and 47 would be up here. 2 and 58 would be up here. 3 and 37 would be here. And 4 and negative 16. Now just a note about graphing, sometimes we're given a graph like we are here, that's our x and y axis are already given for us. But if we didn't have that axis, you always want to look at your table to see what numbers to use. I can see that in my x-axis it goes all the way up to 4. So my x-axis would need to go, we could count by 1s and go up to 4 there. But in my y-axis, I see that my highest number is 18. I'm sorry, my highest number is 58. My lowest number is negative 16. So that tells me that I should count by probably 10s, which they did here. I have to go up to 60 and negative 20, and that's what they did for us already. But it's important to know how to do that when it's not given to us. Now we're not quite finished with this because we do need to connect this. And our parabola would look something like that. Now before we get on to part D here, let's go back to our graphing calculators. Now if you have a CAS calculator, we could have graphed this from the beginning and came up with all the information that we needed. So our equation is negative 16t squared plus 59t plus 4. But the problem is if I type in a t in here, my calculator is not going to know what in the world a t is. It only understands x's as far as graphing is concerned. So I'm going to type in negative 16x squared and then plus 59x and then plus 4. So again, notice how I replace the t's with x's. So now when I hit enter, now you might not see the whole graph. That's okay, because here's what we're going to use. We want to create a table of values so I can see what the time is, or what the height is after certain periods of time. So now if you hit Control and then T, that creates a table. So here's my first 4 values. So that's an easy trick that you can use to get rid of the table. If you hit Control Z, just like you would in Microsoft Word to undo something. And then you can see your graph by moving the grid around, but again, that's not going to help us because you can see that we're going to go all the way up to here. So this is where y is almost 60 there. So that's how you use your graphing calculator, but I want to make sure that you knew how to do that. Just type in the equation like we did here, and then if you want to see the table, just hit Control T for table, and then you can move it up and down, and we can see other values too, but our most important ones are there in the first 4 terms. Okay, let's go back to our notes, and let's finish these up. So let's talk about, it says, is the ball moving at the same average speed? That's referring to the slope. So they tell us between t equals 0 and t equals 1 as between t equals 2 and t equals 3. Remember, the slope formula is, m equals y2 minus y1 over x2 minus x1. In other words, we need 2 coordinates. Well, our 2 coordinates is not what they gave us. They give us that when t is 0 and when t is 1, we want to find the speed between those 2 times. And then we want to find the speed from when t is 2 to 3. So the time is 2 seconds to 3 seconds. Well, I'm going to use my table for that. Well, if I look up above, I can see that after 2 seconds, the ball's gone 58 feet. After 3 seconds, the ball's gone 37 feet. There's only 37 feet in the air, I should say. And after no seconds have gone by, it's 4 feet in the air. And here, after 1 second, it's 47 feet in the air. So now, using my slope formula, 47 minus 4 over 1 minus 0, well, that gives me 47 minus 4 is 43 over 1. So that means it's going up at a rate of 53 feet per second. But here, between 2 and 3 seconds, you're going to see it's going down. So let's see how that reflects as far as our answer is concerned. So I'm going to take, again, my slope is going to be 37 minus 58 over 3 minus 2. Well, 37 minus 58 is a negative 21 over 1. So here I'm going down is what that negative means. I'm going down, or it's dropping, at a rate of 21 feet per second. So I always have students that say, oh, it's impossible, it's not accurate, because here we got a negative speed, and there's no such thing as a negative speed. Well, in this case, the fact that it's negative tells us that it's decreasing, or it's going down at 21 feet per second. Okay, we're not going to bother with the other example. I'm going to stop there. I think you guys have a good enough idea of what to do here. But again, the purpose of this video is to introduce this formula, so you want to make sure that you have that written down in your notes for the height of an object after a certain amount of time. And so good luck on your assignment.